Well, good morning, everybody. Thank you for joining this second session of Zero to Zen. If you were here last week, thank you for returning. Welcome back. If you're new to the program, my name is Jim Dehner. I happen to be a Tableau Zen master. This is the second of 5 sessions. And last week, in session 1, we covered data structure and connecting different data sets together, and how very often you have to restructure the data in your data set to answer the question that you're doing the analysis on. Today, we're going to look at the order of operation, and this is probably the most important topic we're going to cover in these 5 sessions, because it's where most of the problems come about when you're not getting the answer out of Tableau that you thought you should get. Now, in the next 2 weeks, we're going to combine the language of Tableau and calculations. Next week, we're going to cover simple calculations and date functions. And in week 4, we're going to cover LODs and table calculations. And then finally, in week 5, we're going to look at a combination of filters, sets, and parameters. And those are the tools that your users can use to change the view or to interact with the view on the in your workbook. But today we're going to talk about the order of operations. And I like to use this model. I know there's several different models out there for the order of operation. I like to use this model, the 10-step model. And I think we have to start with an understanding of what the order of operation does and what's being accomplished as you create each one of your worksheets. The order of operation is a sequence that Tableau goes through. When you load a data set into Tableau, and it doesn't make any difference if it's a flat file coming from Excel or Google Sheets or whatever, or it comes from, maybe your database, or it's a public site, that data is entered into Tableau, but each one of your worksheets takes a subset of that data and creates a flat file that you can kind of think about like an Excel spreadsheet. And the first thing you do as you go through the order of operation is place headers on the rows and columns on that sheet. And that creates a dimensional table. And you'll hear us use terms like the dimensional table, the underlying table, or just the table. We're talking about the table in your worksheet. And that defines the structure that will be filled with data. And it's a subset of the total of your of the data that you entered into Tableau. After you create the structure, we load it full of values, we do some math, maybe do some calculations along the way, and then create the biz that you see. Now, I like to look at the order of operations in 3 groups. The first 2 steps, step 1 and 2, are extract filters and data source filters, and they work at the workbook level. And they're there to filter out data before it comes into Tableau, reducing the size of the data set, and that just makes your workbook perform better. The next 3 steps, context filters, the creation of sets, fixed LODs, and top-end calculations, and the dimension filters form the structure of the data table on your worksheet. And then the last 5 steps, load that table full of values. That's where we do some math here along the way, we calculate some totals, and we do some table calculations. Now we're going to go through these. I want to start by talking about extract filters and data source filters. I don't know if you use them. I use them occasionally. But the whole purpose here is to make your workbook perform more efficiently. This data set is nothing more than the Superstore data set that came with your copy of Tableau. And this is the full data set. If I come over here to this icon right here, it says View Data, we can look at the entire data set, what's been loaded in, and it's about 10,000 rows of data. Okay. We can come out to the Data Source tab. Okay. And if I want to add a data source filter or an extract filter, I come up here to add a filter, and this should start looking familiar. This looks an awful lot like the filter windows that you see when you just create a filter. We're going to filter the order date based on years, and I just want to look at these 2 years. And you'll notice this window opens and it says year of order date, and I'm only going to keep 2019 and 2020. It tells you exactly what you're keeping. Now, if I go back to that tab, we'll see that only the 2019 and 2020 data is on the sheet. But even more than that, if we come over here and take a look at this tab again and take a look at the total data set, we've only brought in about 6,000 rows of data. So we've reduced the size of the workbook, and the workbook is going to perform more efficiently. That's really all there is to the data source tabs. I do use them. I know some other people use them. You may not use them, but it will help your workbook perform more efficiently. Now, the last 8 steps in the order of operation operate at the worksheet level. Each one of your worksheets has a separate data table or a separate underlying table. The steps that are, step 3 through 5 is where we create the structure for that data table. And it's also where an awful lot of confusions and an awful lot of user errors come up, because they don't really understand when to apply context filters, when to apply dimensional filters, and what happens to the calculation of sets and LODs when they use a context filter. Just keep in mind that context filters are applied before sets, fixed LODs and top ends are calculated, and dimensional filters are applied after. Okay. I want to take a look specifically at the context filter in relation to LODs. And I'm going to use just this very simple example. And I would advise you, when you're learning something new in Tableau, make yourself a very simple data set, something that you can look at and you say, yeah, that did what I expected it to do, or wait a minute, something's wrong here. So we're going to use this data set, and we've just got some produce here, some fruits and veggies, and I've got them broken down into fruits and veg. I've got price and quantity. Price times quantity equals total cost, and I created an LOD here. And this LOD is very simple. In words, it says at the type level, just sum the total cost. So what you see here is the total cost, and the LOD is returning that same value, $5.75 and $2.63. I've also taken produce name and applied a filter on it. And that the filter right now is in context. You can tell it's in context because it's grayed out. Okay, I've applied it in the context filter. That means it's going to be, the filter is going to be applied before the LOD is calculated. So now I can come in here and I can filter out bananas. And when I filter out bananas, the LOD now says $3.75 because the bananas were filtered out before the LOD was calculated. In the same way, I can remove that filter from context. Now it's a blue filter, it's a dimensional filter. It's not going to be applied until step 5 in the order of operation after the LOD is calculated. And now if I filter out bananas, the LOD remains the same. It's $5.75 because it was calculated before we filtered out the bananas. It's pretty straightforward. We usually get a lot of questions, a lot of confusions on this. People will say, well, I want to create a calculation that ignores the filter. Well, Tableau doesn't ignore filters. It doesn't randomly decide when to apply a filter and when not to apply a filter. You as the designer decide when you're going to apply the filter. If you want to apply the filter before the LOD is calculated, then you put the dimension in context. If you want it applied after, then you leave it out of context. Let's see what happens with sets and top end calculations. And this is the same data set. All I've done is I've created a set, and in that set, we're going to look at the top 3 values. And that breaks down the produce into an in set and an out. And the in includes apples, bananas, and green beans based on the total cost. I'm just going to remove the out because it'll make it more apparent what's going on here. And I want to come back and do the same thing I did before. I want to filter out bananas. And we're going to start by filtering out bananas after the set is calculated. And we know that because produce name is not in the context filter, it's a dimension filter. So I'm going to remove bananas. And now we're left with two values, because the third value, bananas, was filtered after it was part of the inset of the top three. We get a lot of questions about this, a lot of confusion. People say, well, I wanted three values and I'm only showing two. Well, what did I do wrong? Well, by now you figured out that what they would need to do is include the produce name in the context filter. And you can see, once again, it's grayed out when we put it in context. Now I can remove bananas, and I'm still going to get three values. Bananas were filtered out before the top three were determined. So now I'm going to see apples, green beans, and spinach. Okay. I want to go over, and now we're going to go to the step 5 of the order of operation. That's the last step that is involved in determining the structure of the table. And I want to look at dimension filters. And you're very familiar with dimension filters because it's probably the second thing you ever learned in Tableau. You created a table and then you started filtering it. And we can look at a dimension filter like this. Now, what I want to show you is how the structure of the data is affected by using a dimension filter. And this, once again, is the full Superstore data set. And if I look over here, this is 10,000 rows of data, just like it was before. And I'm going to filter out office supplies. Now, when I filtered out office supplies, I'm affecting the data table for this specific worksheet. Okay, and we can see what's happened here. We can open up analysis, and we can view the data, and we can look and we can see that we have 32 rows of data. You say, well, that's not 32 rows of data. Remember last week we talked about how Tableau likes narrow and tall worksheets. Well, the actual data table doesn't look like your Excel sheet. It looks like this. Okay? And there's 32 rows, combinations of years, subcategories, and categories. And you can see it down here, 32 rows. And this data set, the data table that's underlying this worksheet, is 4,000 rows. So we've eliminated 6,000 rows of data, and that data is no longer available to this worksheet. We go over here. This will show us the total data that's been entered into Tableau, and it's still 10,000 rows. All the data is 10,000 rows, but this worksheet only has 4,000 rows. You can do the same thing with a continuous filter. And here we have a date filter, and we can look at that filter. And then we can look at analysis again. And we can see that this worksheet is not the same as the one we just looked at. This worksheet has 3,000 rows of data in it. So each worksheet has its own data table. And what you're doing in the first 5 steps of the order of operation is you're taking that full data set and you're breaking it down to create individual subsets of that data for each one of your worksheets, and each one of your worksheets has a separate data table. Okay. It's going to become important as we talk here in the future here. So you saw that we took this data set that has 10,000 rows of data and broke it down to something like 3,000 rows of data that are actually in the individual worksheets. Well, once that data table is created, the last 5 steps of the order of operation load that data table with value, and then we start doing math with them. You know, the IT guy would say, hey, look, that's where you fire off your SQL queries and you bring data into the table. Well, as I told you last week, I'm an engineer. I don't really understand SQL. So we're just going to load data into the table. And we looked last week at data blending. And we said, well, data blending is what you would do, and it happens in step 6 of the order of operation. Data blending is what you use when you're combining data from different data sources, or you're going to work with data from sources that are at different levels of aggregation. But we also said that it always results in an aggregate at the level of the link, or now they call it the blend relationship. At the level of the link, the data is aggregated, and it limits the functionality functionality available in Tableau. We had a data set that looked like this. We were looking at sales by quarter, by category. And we had some goals that looked like this, goals by category by year. And when we did that, we looked and we said, well, we had to create a link between the sales and the goals. And if you recall, we opened this up, we added the blend relationship, started with just category, we added a linkage year. Okay, and we understood that last week. I have added another dimension into these data tables, and that's segment. And we have two segments. We have the consumer and the corporate segment. And you can see here by looking at the chart, the consumer and the corporate section, I have different sales by category by year. But if I look at the goals are the same for consumer and corporate in each one of the years for each one of the categories. Well, why would that be? Well, if you remember, we said the data is aggregated at the level of the link or at the level of the blend relationship. We set up the dimensions in the data table in steps 3, 4, and 5 in the order of operation. Blending doesn't take place until after those dimensions are established. You can no longer filter across that data table at any point except at the level of the link. Well, maybe we can come back and create a LOD expression. Why don't we just take an LOD and write a calculation like fixed segment, total the annual goals, sum the annual goals. But we get an error. And the error message is going to come back and tell us that all the fields in the level of detail expression have to come from the same data source. And this causes real confusion among users. They say, I don't understand why I can't do that. Why can't I do that with blended data? Well, the situation's the same. The LOD expression, fixed LOD, were determined, and the structure for those was set up in step 4. Now we come back in step 6, where we get data and blend data and try to use those in a fixed LOD, and you can't do it unless all the data comes from the same data source. The individual records coming from the secondary data source are no longer available. The only thing that's available at that point are the aggregate data. Now, if we really need it, and what we end up telling people is, well, if you're going to blend data, you have to create a link, and in that link, that link has to be at the level, has to include the level where you want to compare the data. And if we add segment in, now the link is at the category, year, and segment level. Now the goals can be seen by segment. I'm going to move on to the other two types of LOD expressions. We said that fixed LOD expressions are created up in step 4 of the order of operation, and they affect the structure of the data table. Include and exclude are the other two types of LOD, and they are only concerned with the values that are in the data table for the specific worksheet that you're working on. They only work on at the worksheet level and only on the values in that worksheet. We're going to take a look at the example here. And I've got a very simple example for a toy store. I got a couple of different product lines. Each product line has a couple of different products, some customers, and colors. So if I look at that data, and I look at the data in detail, this is how it breaks out at the lowest level, at the color level. There's, for this product, there's quantities of 3 and 2 for a total of 25, and 15 and 9 for a total of 24, and so on. Now, what I'd like to do is I'd like to take a look at the overall averages. And averages in Tableau, just a simple average, are calculated by the by the total quantity divided by the sum of the records, or the count of the records. So here the average is 12.5, and the sum is 24 here, and the average is 12. And I came back and I wrote an include statement so we can see how include works. This very simple include statement. This just says at the level of the product, sum the quantity. And it's written as an include statement. And that's this column over here. And here's the level of product. So we're going to include product and we're going to sum at that level. Now, when we're down below that level, you'll see that the average for the include statement and the average for the simple average are the same. You can look right down the list, 12.5, 12, and so on. But as we move to the next higher level, you'll see the value for the include statement has changed. Now we're looking at a value of 24.5, where the simple average is still the sum of all the records in the data table for this worksheet divided by the total record count. Where now we're looking at 25 and 24, averages 24.5. Where'd those numbers come from? Well, if we go back here, we see at the product level, the total here is 25. The total there is 24. So at the product level, the 25 and the 24, we're going to take the average of that, and it's 24.5. Let's go to the next level up. We'll go to the product line level. And you see the averages haven't changed. So what's happening with an include statement is if you're below the level of the dimension in the include statement, you're looking at detailed data. If you're at or above the level of the dimension in the include statement, Tableau is going to return the value at the product level there. Well, what about exclude? And for that, I'm going to look at the Superstore data, and we're going to look at the map. And I've got two dimensions on the map. I've got a state dimension, and I've got a region dimension. And then what you see there is we've just got the sum of sales, and that's the sum of sales at the state region. But I'd also like to see the sum of sales at the region level on the same map. And we can do that with an exclude statement. And the way this statement works and the way exclude works, it works on the visual that you see. It works on what is actually on, not on the data table, but on the presentation that you see in the visual that you see. We've only got two dimensions here. And what exclude does is to exclude the state level, exclude state, and go to the next higher level, which is region, and sum the sales at that level. I don't want to see the state sales. I want to see the region levels. And when we do that, you can see we have region sales now that are the same for all the states within a region, and I can even come back and I can use that in a calculation to calculate the percent of total within the region and treat each region separately. So exclude will exclude a dimension that's already in the viz. Include you can use to work with a hierarchy and essentially fix at a level within that hierarchy. Collectively, they represent about maybe 20% of all the LODs that you write. Exclude maybe is 5%, include is 15%, fixed is the other 80%. Want to take a look at measure filters. We looked at dimension filters. Dimension filters change the structure of the data table. Measure filters filter based on the values that are in the data table. Okay. And we're going to use, once again, our toy store example. And you can see the data there. And I want to filter on quantity. And as I bring quantity to the filter pane, a window opens up. And the top line on this is all values. What it really should say in engineering talk is at the row level in the data set, each record. Or do we want to use an aggregate? And there's a number of aggregates to choose from. The default is some, but there's a number of aggregates that you can choose from. In this first example, I want to look at the row level. And I want to look at all values that are 15 or less. And when I do that, we're going to see these three values disappear because they are greater than 15. Okay. Sure enough, it worked. I'm just going to show this filter here. Well, let's see what happens when I go to the next higher level. I'm going to aggregate this at the product level. And I see a value here at 24. It's like, well, why would that value still show up? Well, it's because we applied the filter at the row level of the data set. Okay, 15 and 9 is 24. Each of them at the row level is less than or equal to 15. So when I go to the next higher level, those are included, and we see a value of 24. On the other hand, we could bring the quantity to the filter table, and we could filter on the sum. And we're going to do the same thing. We're going to go to 15 or less. And this is the same table we saw at the row level, but when we go to the next higher level, the table has changed substantially. We filtered out everything where the sum that you see on this, in this table is greater than 15. Measure filters and what we just did with the filtering at the record level, big confusion among users. Now that's going to take us to the grand total line. Grand totals in Tableau, you can get them a couple of different ways. I always go to the Analytics tab, drag them out. We have a choice of putting them on rows, columns, or subtotals. We're going to put it on columns. And in this grand total line, we get the total of orders based on category. We get the grand total for orders by year. Now I'm stumbling there because this is not like Excel. In Excel, you create you use the the sigma sign, the summation sign, that actually goes in and totals three values. What's happening in Tableau is Tableau goes to that table that underlies this worksheet and recalculates based on that total table. So it's not just adding three numbers together. And with that, you have a number of options on how you want that grand total to total. We can take a look at total. Total automatically uses the same aggregation as when you brought the measure to the table, to the canvas, or you have your choice. We could look at the averages, for example. And we've gone back and calculated the total based on the average. It's also the average of those three numbers. If you've used grand totals, you've probably been frustrated a little bit because there's times when you don't get a value. Nothing comes back. Well, let's take a look at what's going on here. This is a rather simple table calculation. And we're going to learn about table calculations in just a minute. And all this table calculation does is it calculates the percent difference going down the table between that value and that value, and it's 37 1/3%. But we don't have any grand total. And the reason you don't have a grand total is because mathematically it doesn't make any sense to do that. You can't calculate the percent difference between the grand total row and some other row in the chart. So sometimes you're not going to get an answer in grand totals. Now, one final thing, and this is a really very cool thing that you can do with that grand total line, is sometimes we'll get a question where someone says, hey, look, I want to take a look across regions and I want to know what my total sales were within the region, and then I want to know what the total sales were overall. And at the same time in the chart, I'd like to know what my average sales were by segment so that I can look at my average by segment by region and compare it to the overall average. We can actually do that using one of the very cool things about the grand total line. Size is a table calculation, and all size does, it refers to the total size of the partition that you're looking at. And that gets a little deep for this old engineer. But size equals 1. The only place in the tables that will exist is in the total line and the subtotal line. So you can write an expression. This one says, well, if size equals 1, if I'm in this row, I want to sum sales. I want the sum of sales in those rows. But if I'm not in those rows, and I'm here, for example, I can put a different expression, a different calculation in there. And this is an LOD expression, and we're going to learn a lot about this in week 4. And all this says is at the region and segment level, at that combination, sum the sales, and then I want to take the average of that because I have to have it as a aggregate. But it's important that it's the average. And when I do that, the grand total automatic calculation will take the average going down the table and take the total going across the table. That's going to bring us to table calculations. Table calculations are 10th in the order of operation. They're last in the order of operation. And because they're last in the order of operation, you can take expressions that you created that happened earlier, like LOD expressions, and use them in table calculations. But you can't do the reverse. You can't take a table calculation and fix it using an LOD. And that is probably 20% of the questions we get on table calculations have to do with wanting to fix the value in the LOD and how can I make it, how can I fix that value and use it on another sheet. Table calculations are unique to the data table that underlies the worksheet that you're working on. As we saw before, a different sheet has a different table. You can't transport a table calculation from one sheet to another sheet. Okay. The other thing about table calculations is they always result in an aggregate. The outcome from a table calculation is always an aggregate. Now, this is the one time where I'm going to tell you to think about that data table just like an Excel spreadsheet. Think about rows and columns just like an Excel spreadsheet, because table calculations work with that thought in mind. And we talk about scope and direction. Scope is how much of the table is being used in the calculation within any single calculation. And direction is either across or down. And you'll see how that works out here in just a second. So keep thinking scope and direction. If you want to apply a table calculation, the easiest way to do it is you have a table, we've got sum of sales here. I can go to a quick table calculation, and there's a number of calculations that are already predetermined for you. We're going to look at percent of total. Okay. And Tableau has created the percent of total, but you'll notice that it goes across the table, and we wanted to know the monthly percent on total. Okay. The default is across. The direction is across, but I can change that direction by opening up that little caret, compute using, and there's several ways of doing this, but we're just going to compute down. We're going to change the direction from across the table to down the table. And sure enough, we get our percent by month, by year. Now, I told you we can also nest calculations like LOD expressions in a table calculation. And we get this type of question on a fairly regular basis. Someone will say, hey, I want to know the rank of my subcategories by segment, and I want to see how that changed over time. I want to see how that changed each year. I want to see how that changed each month. Well, to start with, we need to determine what the total sales were by segment by month. And to do that, we're going to use a table calculation or a LOD expression. And this expression in words says take all the combinations of segment, subcategory, and the year of order date, total the sales at that level, and save it under this name so I can come back and use it later. We've changed the structure of the data table so that we can do this. Okay, and that's what these values are here. Well, there's 3 segments, 17 subcategories, and 4 years, so that's 204 values. Okay, I did the math, but you could also look down here, and it's 204 values, and that's the number of marks that are in the table. Now I can come back and I can use that expression. We're going to look at that. We can use it in a table calculation. Rank and rank unique and rank in all its forms are table calculations. Okay, and we take that LOD expression, we take the sum of that, because an LOD expression is always an aggregate, and we want to take the sum of that descending. We can bring that to the table, and I'm just going to not show the total values. They have to remain in the table. We can't just eliminate them from the table. And now we can look at the ranking. And sure enough, Tableau did the ranking across the table, and that's clearly not what we wanted. We can open the table calculation, come down to Edit Table Calculation, and it opens a window. And this is going to, and I'm doing this to emphasize the idea of scope and direction. As long as this box is checked off, the calculation assistant, the highlight will show you both the scope and the direction. We're going across the table and we're looking at the table across each row. But we know that's not what we want. We want it to include subcategory. By going specific dimensions, we can select which dimensions we want. This could also be done using some of these, but I wanted to do this to show you scope. And you can see as soon as I did that, the entire table was highlighted. The scope of this rank calculation now is the entire table. And you can see it goes through values from 1 to 204. And once again, that's clearly not what we wanted to do. We wanted to look at each segment, so we're going to restart this based on every segment. Excuse me. And when we do that, we get what we're looking for. We get the ranking down the table or by segment by year. And you can see the phones were 3rd in office in 2016, but they were 1st in office in 2019. And so on. Table calculations also allow you to navigate that data table. They're kind of like offsets in Excel, if you've ever used offsets in Excel, but they work in a little different fashion. There's 5 functions that are available to you to navigate the table. First and last are the first cell and the last cell in a row or a column. Index is the count across, 1, 2, 3, 4, 5, across the columns or down the rows, 1, 2, 3, 4, 5. Previous value is going to return the immediately preceding value, and lookup allows you to determine how far away from a cell you want to go and return the value from that location. Let's take a look at lookup. I've just created a table here and I've got a value. I just added sales, so we got sum of sales and by subcategory.
And Jim,
I want to take a look.
Got a time check.
Okay, I'm very close to being done here. We're going to run about 5 minutes, a little long.
No worries.
Okay. We're going to take a look here. The lookup function just says, I want to take a look at the sum of sales. Go to the column marked sales. And based on the row where I am, I want to go -1. -1 vertical is up, 1 vertical is down. Okay, so sum of sales -1, you can see we're offset by 1 in each location. So this is this column. I'm looking up this column -1 location. You can also use first. We talked about what first was. It's the first value in the column. This says look up in the sales column and return the first value. So all of these are the first value in that column. And then you can do some math if you wish. Okay. And this just says return the value from the sales column in the row that I am. That's what 0 means. Minus, look up first. So this is the difference between what you see here and each one of those values. So lookup allows you to navigate the table. There's one other thing that we can do with table calculations, and that's we can use them in filters. Some people call them table filters or table calculation filters. I primarily use them to hide different parts of the table. I refer to them as show hide filters. I like to think of it as a window. You start with the view that you see there, and you're looking through a window and you see all the values in that window. But I want to narrow that down, and I only want to see some of the values in the window. But I don't want to change this underlying chart. And the question usually comes is, I only want to see the last 12 values in this calculation, and it's a running total. The running total started 2 years ago, and I want to continue that value. I don't want to restart the calculation at 0. And if I just filter the data, what happens is the first value becomes 0, and I lose the sense of history. So you can create a calculation that looks like this. And this is the last we're going to look at here. This says nothing more than if last is less than 12, which means show me the last 12 values in the table, then show, or if it's not, hide. I'm going to show hide filter here. When I hide the data, I'm seeing the last 12 values, but it starts not at 0, but it starts at the value that was in January. This will update automatically. Next month, when January rolls around and they got January data, he'll only see 12 values. Okay, that's what I wanted to go through. I hope you have a better appreciation for the order of operation, how the first part of the order of operation creates this flat table, and each worksheet has its own dimensional table. And then after that dimensional table is created, we load values into that table and you make your chart. Next week, we're going to take a look at calculations, and we're going to look at the first 2 of the 4 basic types of calculations. We're going to look at simple calculations and date functions.